Hello, this is Matt Gaskill, Philosophy 160. Today I'm presenting problem 1.18.20. So in this problem, we need some information from the previous problem, question 19, and also from section 1.15 in the book. In that section and in problem 19, we know that if we have an argument, circle, therefore triangle, if we know that argument is valid, then the associated conditional statement, circle only if triangle, is a tautology. In other words, the truth values for circle and triangle can never be true and false. So you can never have circle true and triangle false at the same time. It's just not within the realm of possibility. It doesn't exist in this universe for whatever reason. And so, as an example, we'll take modus ponens, we know is a valid argument, and we're going to conjoin the, the two premises with the conjunction operator, and then we'll add the conditional conclusion to construct an argument. And so we get an argument as shown, where we've got the first premise conjoined with the second premise, therefore Q. And if you look through the truth table, you'll see that for the dominant operation of the premises, which is this conjunction, we're going to call all of this our circle. The truth values are T, F, F, T, and then our triangle, which is just Q, are T, F, T, F. And you'll notice that the values T and F, T for circle, in other words, T for our dominant operation of our premises, and the truth value for Q, we never see a TF. We get TT, FF, FT, and FF. So this is what we mean when we're saying that within the universe, you're never going to get a truth value of composed of T and F in that order. So using this information now, we're going to go look at problem 20. So in problem 20, we're given a couple of conditions. We're told circle, therefore triangle. And we're also told triangle does not lead to circle, or not triangle there. And we're also given a set of requirements. So we're asked to find a square such that circle, therefore square, square, therefore triangle work out, and then, but it doesn't work out the other direction. So square, therefore circle is not a logical kind of flow, and triangle, therefore square, also doesn't follow. And our goal is to construct a sort of a logical syllogism where we move from left to right, from circle through square to triangle, but it shouldn't work the other way. And so given the conditions, circle, therefore triangle, we know that the conditional circle, therefore triangle, or sorry, circle only if triangle, the values of T and F don't exist. So we saw that in the previous slide. But also we know that the values of FT must exist in order to meet the second condition. And then for the four arguments, the four requirements that were given, we have similar interpretations. So here are the 4 tests that our square is required to meet. And we can set up kind of our test apparatus for each of them, which is a truth table for each pair of circle triangles for each of the requirements that we've got set up. And we start with our conditions. So these are what we're told. This is the lay of the land, if you will. This establishes our universe of truth values. And we know that because circle, therefore triangle is a valid argument, that T and F doesn't exist anywhere. So we go ahead and we just kind of darken out those rows in each of our tests. We don't even have to evaluate them. They don't exist, because that's what we're told in our conditions. And additionally, certain values of the conditionals are defined independent of the value of square. It doesn't matter what square is. So for instance, when circle is false, we already know that the argument circle only if square is true. So we know that's true for these 2 cases in the first test. In the second tautology, when the consequent, in this case triangle, is true, it doesn't matter what the antecedent is. We already know that the result for the argument will be true. So we go ahead and mark those off as true. In the case of the non-tautological requirements, we know that, so in these requirements, we need to get a combination. Well, we need to have at least one of these 4 interpretations needs to be false in order for the overall truth table to be non-tautological. One of them is taken away, as we can't even evaluate it. It's not in the realm of possibility. So we've got 3 chances to get a false condition for this argument of square only if circle. Again, in the case of TT, where circle is true and circle in this case is the consequent, then we know this interpretation to be true, irrespective of the value of square. And in the last non-tautological requirement, the antecedent is false, and so the overall value of the argument is true, again, irrespective of what square is. So we've got a couple of rows knocked out here before we even have to start thinking about square. So if we look at square and we think of square as some kind of a statement, if you will, composed of circles and triangles, then we need to think about what those values need to be. In the case of the 2 tautological requirements, we know that we need the overall value of that interpretation to be true. Otherwise, we won't have a tautology. So in order to make this first case true, we need the value of square to be true, because circle is already defined as true. And if we were to allow square to be false, we would get a false value for this argument, and then we'd have a non-tautology. So in order to meet this requirement, when circle is true and triangle is true, the value of the statement that we construct, which is square, it needs to be true. If we move over to the other tautology, that's the same idea, that we need all of our interpretations to be true. The value of triangle here is false, which means that we need square to be false in this interpretation in order for the overall value of the argument, square only if triangle, to be true. So we're trying to set up a false situation between square and triangle. So square, when circle is false and triangle is false, we need the value of that statement that we're calling square, we need it to be false in order for the second tautology requirement to be satisfied. So, and those are the only things that we have to play with in those two tables, because each of them only had one open row until we, answered those two questions about the value of square, what it needed to be. And then since we know now what the value of square when we've got circle T and triangle T, and we know the value of square when we've got circle and triangle both false, we can go ahead and populate the other rows in the non-tautology requirements. So we can populate square FF. It needs to be false. It's the same. It needs to be false because it has to match the previous interpretation of square false false. And then we've got square TT also true, just copied down from the first table. And that leaves us now in the non-tautological requirements. We've got one row open in each. And again, for these non-tautology requirements, we need at least one row to be false in order to close that off from being a tautology. We already know that in the case of square FF, that this F value is going to give us a true statement. So that's why it's blue. It's going to give us a true statement. So we've got our only chance now is for the FT case to be false. And in order for the FT case to be false, we've got circle is false. So we have to have the antecedent, we have to have the square be true. So we get a true false argument with our conditional, so we can make that row false. So we need square to be true over here in this table, but in the last table, we need square FT, we need it to be false for the same reasons, but we're flipping it because in this case, square is now the consequent and triangle is the antecedent, and triangle is true. So we've got to set up a true false situation here, which means that square has to be false. But this is creating us a problem because in the first case, we need square FT to be true. And in the other case, we need square FT to be false. And so what we have to do is we've got to somehow find a square that can do that. And the way that we propose to do it is to add another variable. So we've got a circle, we've got square in terms of circle, triangle, and now we've created a new shape, we call it spade. Could have been diamond, but spade looked nice. And so what we've done is we've just gone through and we've added kind of the spade symbol to each of our kind of requirements tables here and see what that can do for us. And so we think now, because we have this additional term that we can play with, that we can set up a condition, a sentence for square that is able to be true in one case of circle and triangle being FT, but false in another case. Now, one thing that we notice is that to help us along, because we need to invent a sentence based on now circle, triangle, and spade that will meet all of these requirements, these 4 requirements, given the 2 conditions that we previously had. So to help us think about how that sentence might look, we make an observation that whenever the square is true, it's the case that triangle must also be true. So we've got triangle true here, and when square is true here, again in the non-tautology, square is true, triangle's true, and in the last non-tautology, square is true and triangle's true. It's not the other way around. You'll notice down here, triangle's true, but we want square to be false. So this statement, it only works in one direction. So whenever square is true, triangle must be true as well. So we propose one possible solution, which is the sentence where square is triangle and either circle or spade. And you can see that with this conjunction here, that drives this triangle to be true whenever square is true. Now what we can do is feed our candidate square solution back into each of the tables and test the open interpretations and see if it works for us. So the first tautology, we just feed in the values. So we've got our circle, it's true for this interpretation. We've got our triangle, which is true, and we've got our circle, which is true. And we have our spade. We don't have the value determined right now, but we'll see that because this is an or statement, it doesn't matter what the value of the spade is. We've already got a true coming out of this or statement. It's an inclusive or. And that's conjuncted with the true from the triangle. So this overall statement is true. And we've got true only if true. That's a true statement. And so we get the blue check mark. We pass the first test in that our proposed solution is a tautology for circle only if square. The other easy one is the other tautology. And again, we just feed in triangle's false, circle's false, and then again, we have this spade with an undetermined value. It's either true or it's false. But because we have this conjunction here, we have a false and it doesn't matter what the and is because they would, both the left and the right would need to be true for our antecedent to be true, but it's not. We have this false, which drives the overall value of the antecedent to false. And a false antecedent, only a false consequent, that's a true statement. And so we get a blue check mark. We pass the second tautology requirement. Now we go ahead and we feed in that false, those false, or the statements we just checked in the tautologies, we just feed them back down into the non-tautology requirements. We already know that they're true values. We give them blue check marks. Now we go ahead and we evaluate those FT interpretations for the non-tautology requirements. We've got the true from the triangle. We've got the false from the circle, and then we have this or, and we're leading into an only if a false. So if the antecedent is true, which is what we're looking for this interpretation, then we're going to get a false value for the overall argument, which will make this table a non-tautology. Now we can see if spade is true, then this or value becomes true, which means that this total conjunction becomes true. So our antecedent is true only if a false consequent, so that would work out. And in the other case where spade is false, then it doesn't work out. If we look at the other side, so there's a good possibility, there's no guarantee that that there's a tautology here, that spade sets up the situation where we can't guarantee a tautology. So that's looking pretty good. We'll come back to that in a moment. And then the other FT, we've got this true only if, and again, we need a false consequent here. We've got a true circle, a true triangle, and a false circle. So we need that spade to be false in order for the or to be false, which gives us an overall false for the conjugation. So that would give us a false consequent. That's what we're looking for. So there is a spade that would give us that, a false spade. And then if it's a true spade, then it would allow it to go through again as a true value, as a tautology. Again, with spade being able to be true or false, we can't guarantee that this requirement will be a tautology, which is what we're looking for. And so with the values of square, FT, and spade, it's completely dependent on the value of spade. And so it can't be guaranteed as a tautology. So let's go ahead and we'll expand our tables. We'll look at the two tautology tables first and see what interpretations we get now that we add spade to our tree, so to our table. So our table doubled in size to 4 to 8, from 4 to 8 rows to 8 rows. And we've entered the values of spade. So the first row, spade is true, and in the second row, spade is false. Now, we already had said for these two tautology cases that the value of spade didn't matter. It doesn't affect the overall value of the or, because we already have the true value from circle, which drives that value. And this just demonstrates how and why we didn't care. And in the second tautology, it's the same situation. The left input for the conjunction, because it's false, it already drives the overall conjunction, the overall antecedent, to be false. And so we end up with tautologies in all the cases. And again, we're ignoring the cases where circle is true and triangle's false, because that's the condition we're given. So let's look at now the non-tautological requirements. And this is where the value of spade does have an influence. So if we look at the cases where the value of spade matters, and where we're looking to get a false value in order to meet the requirement, in the TFT case for the first non-tautology, we can see that the value of spade is true, which drives the overall or value to be true, combined with the left input of the conjunction being true, gives us the antecedent itself true, feeding into an only if false. So we have a false argument, false statement. And so that means now that we got at least one row in this table which is false, demonstrating that it's not a tautology. So our statement so far has passed 3 of the 4 tests. And in the last test, it's the FFT case that we were having trouble with. And again, we feed back in the value of spade, false in this case. The OR value becomes false. Both left and right inputs to the OR are false. And because we had a false value on the right of the conjunction, the overall conjunction, our consequent, becomes false. So we've got true, only a false. That's a false statement. So that closes off this row. And so it's a non-tautology. And so our proposed statement for square, which is triangle and either circle or spade, it satisfies all conditions and requirements. And that's one answer for problem 1.18.20. As always, if you have any questions, hit me up on Prano. Thanks.